Alrighty, with that said, let's jump into chapter 25. Welding. All right, welding, permanent fastening, right? Okay. So in essence, when we talk about welding, that's in essence what we're trying to look at. Let's look at the first figure of the chapter here and kind of get an idea for what we're looking at. All right, a couple components on a welded drawing. Now, us as drafters, this is a very complex trade. It takes people a while to learn it, and it's a lot like this one. I mean, we give you a good round base in here, I feel, but then you're going to hit the work first, you're going to keep learning, and it's going to be 2-3 years before you feel pretty comfortable on where you're at, because your learning curve is going to be so steep. That's the same way with this stuff. They spend a year in that welding lab over there, actually 2 years, it's different than ours, and they just got a base. And then they've got to go out and perfect their trade after that. But there's a lot of it. I mean, and I don't pretend to be a welding guy. I'm not. I mean, I can certainly step out and burn a little all rod and fix something very minor, but there's no way I'm doing a pipe or stainless or aluminum or any of that stuff that these people can do. Now, with that said, how do we go about putting together a welding drawing? Well, we get some advice. We get it from either the engineer on staff or somebody in the shop who knows this stuff is giving us some of that. So there's going to be some collaboration that goes in. I know whenever I've got a weld I need to do, first thing I do is sketch it up, make sure I got my situation all hammered out, and then I go talk to somebody who welds for a living and say, what do I need to get on here? When you look at a welding drawing like this one right here, first thing to know, it is an assembly drawing. And in essence, we are doing an assembly drawing. Now, when we talked about assemblies, we had 3 types. We had an outline, section, and exploded. Remember those 3? In essence, this is going to be a different assembly drawing. It's going to be a multi-view with the weld notes on it. So welding drawing is an assembly shown in multi-view configuration. That's a general rule. When you look at this, notice as they point, so obviously there's some of these notes right here, which is a weld symbol. You come down into here, we see a flange. First thing, don't show the weldment. The weldment is the material we place in the object. We do not show it. All we do is put a note that shows the process. Now we're going to get into what all these symbols mean. I think you're going to see a lot of similarities on these with thread notes. The only thing is that thread notes you're going to think are fairly easy compared to weld notes, because thread notes are pretty much everything's laid out, right? You got a size, you got a TPI, you got a form, and that's about it. With these, we will have some varying that goes on with them due to the different processes involved. Now let's talk about welding for a minute. When you talk about welding, what does everybody kind of think of with welding? There's a few pictures on the next page. Is this kind of what you picture, like this guy here down on the bottom, sitting here with a mask, and he's got this bright light in there. By the way, don't look at it if you see it when we go to the welding lab. It's as bright as the sun almost, and it will burn your eyes. This is kind of what we picture, right? Now, we certainly saw some of this when we went to the trailer manufacturer. Remember going to Western Trailer, where you saw some people welding? You also saw an automatic welder when they were putting the I-beams together. So there was some of that went on. When we weld, there's really 2 processes that kind of globally affect everything, and it's in this chart up here above it. Okay, so when you're welding, we're either going to go one of 2 routes. You're going to go to a solid state, which we're not really going to discuss. When we talk about solid state, we're talking about forging, friction fits, or what we call cold rolling. And we're not really going to discuss that because these are generally done in some plant. They're not done out in the field as a general rule. So very rarely do they hit our drawings unless you happen to be in the steel industry and you're making shapes. The other process is liquid state. That's this one over here. Now from here you can go several different ways. So we've got our electric arc, which is what everybody's kind of used to seeing, where we use electricity to heat up the surface and the weldment material till they're in liquid state and they kind of commingle while they're liquid, and then as it cools it all solidifies into the same unit. That's our real common one. Certainly we've got a lot of these that go on out in the field too, such as spots and seams. And we'll talk more about those in a minute. But for the most part, your liquid state. In essence, we are going to heat some surface up. We are going to melt it. We are going to add another material to it. Then let it cool as one unit. Now the weldment is the material we add to it. The thing to know about the weldment is that somebody, whoever specs it out for you, they will always make it stronger than the material you're welding. Because we do want this to be a permanent fastener. If this thing's going to break, we don't want to break it at the weld. Okay? The weld should never break. Any questions so far? How many people in here have done a little welding? I know I asked this the other day, but Juan, I think you raised your hand. You've done a little welding, haven't you? No, you haven't.
Well, soldering is considered welding.
Soldering is considered welding.
Then I will.
Yeah.
Oh, yeah, a little.
Yeah, little electronic unit and
Yeah.
melt a little
Yeah.
brass or something into it, or copper. Okay. Yeah, certainly that's welding. Okay.
Is hot glass, that wouldn't be welding, you don't add anything to it. When you-
It's still considered welding. Now, when I say we're adding material to it, I'm generally talking steel or metals. Yeah, you can weld about anything. Glass, yes, it's considered welding. When a guy comes out and fixes a little chip in your screen, in your windshield, he's welding it. Now that one he's adding to it, but certainly you can, blow glass or add things to it, and you're not adding stuff to it. In mining, one of our biggest things, believe it or not, was not welding metal, it was welding plastic. We did a lot of plastic welding for all our piping. All our piping was plastic because it had to be movable and go through things. We had big machines that you would put around a pipe and it would melt them together. And it was pretty constant. It was going 24/7 on our mine sites. And certainly we had people in the truck shop doing the standard welding all the time also. When we talk about welding, we're going to talk about quite a few different types, but they're all set up for really these situations of our material. Okay. So this is really what's going to drive what you do as far as a weld and the type of weld you do. And it's really the configuration of the parts. The first thing we've got is what we call a butt weld. Okay. That's any time two pieces are faced up to each other. That's a butt weld. This is almost always a groove or a bevel groove weld. So butting two things up, making them bigger. Next one's a lap. Anytime you have two materials that overlap each other, then we do a lap. This is almost always a fillet weld, which is probably the most widely used one. So a lap situation. Coming in perpendicular, or any angle really, we call it a T. The harder ones, the corner. This thing's pretty tough to do for a welder.
You fill that in?
Yep, they fill it right across the top. What we'll do is we'll bevel these sides and then either use a fillet or a groove weld on it. The hardest part, believe it or not, is just holding the materials in place while you weld it. It's one of those cases you need 3 arms. The last one is when we have two things faced up on each other, we have an edge weld. And we come around the edges. We can also drill holes through it and fill those holes and come into here to join these together. Okay, keep in mind, once this thing's welded, like this, say we got this lap thing welded. Once it's welded and we put a big weight out here, this thing should not come apart right here. We should snap that plate off before that weld breaks, okay, whatever that material is. So these are your 5 configurations that will really kind of spell out how your weld is going to progress. Yes, sir.
On these, do you just do those edges, or do you go on the sides as well?
Which one?
Well, like on the lap.
On the lap, we would go on this side and maybe along the bottom also. Now, we could get in, if we really had to have some big strength and we were a little bit worried about it, we could do an edge weld, or a butt weld, right? I guess an edge would be really what we're at here. Okay, so we can do that. Typically, I don't know that we would need to.
Except the edge, is the edge weld, is it just on the top and the bottom?
No, we would do the edge weld would only be here and on the back side.
I'm sorry, I skipped down to the bottom one.
Oh, the edge one?
Yes, so you just again do the top and the bottom and you don't do the sides.
Again, it would depend on the strength that you need and what you need. You know, we do it, and you're gonna see this a little bit later in our little talk this morning, is we can come in and just do a little section here, here, and here. We can do the whole thing. We can do maybe one here, one here, one here, one here. We can do all this with our notes. We can tell them exactly where we need stuff. And again, this is really the purview of an engineer, right? For them to give you this information, and then you put it together. So in essence, on the purpose of our talk, don't lose sight. What we really need to be able to do is we need to be able to apply these to a drawing. You'll like AutoCAD's got a couple things for you on this. We'll get to there.
I hope they have the symbols in
Any questions so far? Okay, let's move over to page 1191. And let's talk about a weld symbol. So first off, a weld symbol is a multi-leader, but it's got a little bit different shape. We follow the old protocol, we try and get it a 1/2 inch off the object. Now, so you're going to have your leader line that comes up here. Now we do an 1/8 inch shoulder, right? We do an 1/8 inch shoulder here. On a weld symbol, we call that, the shoulder, a reference line. And this is where all our information is going to sit. It will just come out a ways. Now it has a tail on the end. You won't see the tail on every single one. The tail is optional. One thing I should state before I get too far into this, down here is a quick cheat sheet on where everything goes. The stuff goes on this reference line right here in this order, regardless of which side the arrow's on. Okay. So for an example, let's say this is going to be a fillet weld. What I would do is I'd come in and say, you know, I want a 1/4 inch fillet weld, and I would put it right here. Okay. So basically I have my size, which you see the size is right here. And then here's my symbol for a fillet weld. Now if I went and said, okay, that's the same thing, now let's switch the arrow to this side, so it's not here, it still looks just like this. The reference line always reads left to right, regardless of where the arrow's at. Like I did mention, the tail on there is optional. If you do have to draw the tail, this is not in AutoCAD, just draw a 30-degree line for a 1/4 inch. Okay. This sheet right here, you ought to spend a little time with this because it's a really nice little cheat sheet. I'm going to kind of go over this and then we'll go look at a weld symbol and see where it's at. I'm just going to hit the major points. First off, the symbols will be here in the weld symbol in the middle. Okay. That's where your symbol goes for the different types of welds. We'll look at those in a minute. You put the size of the weld to the left of it. Now, when we get into different symbols, there's going to be a couple different ways of doing things, but this is a general rule. So your size is here. Over on the right side of the symbol, you have the length and the pitch. So the length of the weld is fairly straightforward. It's how long the bead is. When I say a bead, that's how long the weld is. What's pitch? You folks know that term. The definition doesn't change here. Pitch is the distance from the spot on one tooth to the same spot on the next tooth, right? Here, it's the distance from one spot on one weld to the same spot on the next weld. Same definition. So you can have pitch. Now that's across the top. You do see some things up here. There are some angles and sizes that go on up here with specific welds that are right above the symbol. And you'll see those in a minute. In the tail is where you put miscellaneous information. Okay. So they say specification, process, or other reference on here. And in essence, really, what I see here is this is an opportunity for you to write notes. So you might say GSAW, which stands for gas arc weld. Or you might say a TIG weld or a MIG weld if we have to go through a defined process for that weld. Okay. Generally, we don't get into these very often. Okay, that's usually left to the craftsman. Over on the front side of it, right on the shoulder, you do have two symbols that you should be aware of. Okay. The first one is this black flag. What that means is that that will be welded in the field, or this object is going to be assembled wherever the project is. We're not going to do it in a factory. We're not doing it somewhere off-site. Okay. So that's a field weld, which a lot of stuff like that happens. The circle that's around here means you're just going to weld all the way around the thing, no stops. And if that's the case, you may or may not need a side. You certainly don't need a length or a pitch. That's your all-around symbol. Okay, that's generically most of it. So keep in mind, weld symbol in the middle, size to the left, length and pitch to the right, and that's generally as far as you will take these. Now, yes?
If you're going this way, would you move your flag and your circle weld to that side?
Yes, it always sits right
That would
there.
move back and forth.
Yep, it goes right to here.
That would go here.
Yep.
The
Now-
circle and the flag go to the leader.
What's that?
The circle and the flag always go to the leader.
Yes, the all around. Mhm. Follow the leader.
Okay.
You'll notice on here as they look through there, they got kind of the same information top and bottom. Okay? Because the same information can occur top and bottom. In essence, what you're looking at is the arrow. Okay? When you got information on the bottom of the line, you are welding the side the arrow is pointing to. If it's on top of the line, you're welding the other side of the joint. Did I remember that right, John?
I think so. I always had a hard time remembering that.
I got it right, I'm pretty sure. I'm 99.9%.
Okay, wait a minute, so if there's something written on the top, but then on the bottom, the arrow goes this way, which side are you doing?
Let's go look at it.
The other side.
Let's jump back
That
to
makes a lot
figure
of sense.
25-1. Okay, let's look back on figure 25-1. And let's see this in action. All right, let's start down towards the bottom. Here we have a weld that's going on, 1/4 inch fillet weld. Notice it's pointing to where this wide flange beam meets this little bar right here. It looks like it's 1/2 inch plate. Okay? The arrow is pointing to this side of it. Okay? This part right here is talking about that. Or, excuse me, I just did that backwards. Shouldn't have asked you, Sean.
Jeez.
That side is talking about that one,
What?
the opposite side. Do this. This side is talking about that one. This side is talking about that one.
And it's shown in the shot with the little black flag.
Mhm.
So it's not a left, right, it's a. what,
Text reads left to right, always. Text reads left to right, always. This is a size, right? This is my weld symbol. Okay. Do we got one on here that just has one side? Yeah, we got kind of a funky one here. It's actually not a great figure to look at, because everything's the same. But if I wanted to just weld this side right here, I can keep this leader in the same spot, but I would remove that. Okay? The bottom talks about the side the arrow is pointing to. The top talks about the other side of the joint. And that's a good thing. It gives you flexibility on where you're placing these multi-leaders.
So do they ever do a thing where they would be pointing, the top would be there but not the bottom? So it's pointing here, but you weld over here?
Mm-hmm. Yep.
It'd be much easier if you
Happens
could
all
just
the
make the
time.
top of the arrow.
Yeah, I'm not sure why they went to the bottom. That common sense would say the top goes
Yeah.
with the arrow, right? But it doesn't.
That's why I always had such a hard
There's just
time.
opposite what you think is smart.
Here's an example of one that's got pitch and length, and it's a field weld, right? So here we've got, again, some plate right here. We've got another one. We're going to go ahead and weld that joint right there. And I don't know if this is an edge weld or if it's a lap weld. I can't really see what the other dimension to it, but it's going to be done in the field, right? Okay. It's a 3/16 fillet weld, both sides. So we're doing this side and the back side we can't see. Okay. And then it's got a length weld of 3 and a pitch of 12. So what that means, they're going to come in here and they're going to apply a little 3-inch weld, and then they're going to come over, do another 3-inch, where there is 12 in between those. Okay. So there's my pitch. There's my side.
And the welds are on center.
Yeah. Okay. But just like our definition of pitch. So that's what this note is telling us. It also got a little special area right here for you to talk to the welder. 18 inches continuous on each end. Okay, so on the ends, we're going to just fasten this baby down, and it's not moving. And then throughout the span, every 12, we're going to put a 3. Okay, you good with the symbol a little bit?
Okay, say it again, what's about the 18 inches? This is gonna go,
Well, according to that note, it says 18 inches continuous on each end. So I'm guessing this is a wide flange beam of some type, right? And they're welding it to a plate. So it's got 2 ends. We're gonna weld that 18 inches on each end. This thing could be 30 feet long, we don't know.
okay, wait, I'm so confused. You're not doing this 3/16 with the pitch, the 3/12 along the whole length?
No. No, on the
You're
ends,
doing it on the ends.
you're doing 18 inches straight, 1.5 feet. There's gonna be a continuous weld on the end, right? This thing's broken, it stretches out here a long
Okay,
way.
so each end has 18, then you start your 3/12,
Yep.
then you,
Mhm.
okay.
Yep.
And the 3/16 refers to the size of the dwelling.
Yeah, so if I was to spin that guy, and let's say it looks something like this. And it looks to me like there's some plate right here, so we're doing a fill-up well. It's gonna be right in, probably something like that. Okay, and that 3/16 is the size. Now what that's saying is that this will be 0.18 on this dimension, and then this one would be 0.18 also. Okay. And generally, we just try and match our material. Keep in mind that this is an assembly drawing. What you're doing is trying to give them instructions on how to put this thing together. I want to go to page 1193, figure 2513. I wish the author gave us a chart like this in all of our little sections that would set out so well. This is grid paper set up to an 1/8 inch. So if you have to draw any of these symbols, use this as a guide. Okay, these things are a little bigger than normally we would do, because normally we do 1/8 inch for pretty much everything, right? Okay, the only thing we got, I think, 1/4 inch is our section cutting plane lines, the arrows on. Almost everything else is an 1/8. When you're doing a weld symbol, most of them are bigger. Okay? They want them to stand out, because remember, it's an assembly drawing. So, you know, I've noticed these, if that's an 1/8 inch grid, that's 1/4 inch high, 1/4 inch wide. You get down to some of these others, like seam weld, they're a 1/2 inch.